So here we go. We're going to work our way through problem 45. So we have a weight attached to the free end of a light string wrapped around a reel with radius of whatever and a mass of whatever. The reel is a solid disc, free to rotate in a vertical plane about its horizontal axis passing through its center. The weight is released 6 meters above the floor. A, determine the tension of the string, the acceleration of the mass, and the speed it hits the floor. B, find the speed calculating part A using conservation of energy. So as promised, we're going to do this problem both ways. Now, if you're wondering what this looks like, there's a problem, a sample problem in the textbook that models that, and that is exactly here. So we have a solid disk about an axis, and there it goes. So the mass is going to descend and unreeling some of this. So looking at that problem would be a good way of doing this as well, just to help out. So I'm going to put the book up there, and I'll write down some knowns, but let's work our way through this process. So at any point, if you want to give something a try before seeing me do it, just shut the video off and go for it. So here we go. So given that part A is asking about accelerations and tensions, the first thing I want to do is use this, do this problem vis-a-vis a torque analysis. So here I am, I have my pulley, it's a solid disc, I'm putting my rotational axis in right away, there's my mass, and I'm told that it is 6 meters above the ground. So here we go, 6 meters. I'm going to call this mass 1, I'm going to call the pulley mass 2. I know that the weight of mass 1 is equal to 50 newtons, right? And so I'm just going to put that in, that's FG1, FG1. I can put in FP1, not that it matters. There must be some sort of normal force here holding it up. There's got to be, otherwise the pulley would fall. I'm just going to call this tension and tension. There's no need to give elaborate names to it because I'm not worried about multiple tensions in this problem. Okay, so that's our setup there. We know that the mass of the pulley is 3 kilograms, or mass 2 in this case is 3 kilograms, and the radius of object 2 we are given as 0.25 meters. So there we go as some setup pieces, and we know it is a disk, right? We always want to be looking for that in a problem if they give us something about the shape, because that's going to affect what moment of inertia equation that we're using. So in terms of setup, I want to, now that I have my free body diagram, I'm going to talk about axes. So I'm going to have a positive x-axis be my axis along this way. We're still using a bent axis because if I don't use the bent axis, I'm going to get myself into trouble with signs. All right, so here we go. I'm just going to start off with a sum of forces equation on mass 1 in that x dimension, so mass 1, a1x. And so that's just simply Fg1 minus T is equal to M1A1X. Not much more I can do there. I don't even care about putting in M1G here because I actually have 50 newtons. In fact, this is a numbers problem, so why don't we just go right ahead and start putting in what we know. Oh, damn it, I guess I do need that mass. So Fg1 is equal to M1G, and so 50 newtons is equal to M1 times 9.8 newtons per kilogram. And I'm going to have to look that up in a second because my phone is being used as my device.